Okay, so hi everyone. So today we are going to discuss about the key cipher technique. So let us look at the concept of key ciphering, how encryption and decryption is done using key ciphering. So it is one of the kind of block cipher technique. So the algorithm used in key ciphering is, so we can say C is equal to K times P mod 26. So this is the algorithm used with the encryptor side. So this is encryption. So where C is my ciphertext and K is my key, which is a dimension of n cross n. So let us look at some examples. So P is my plain text and we are going to perform under mod 26. So this is the encryption algorithm using the key ciphering. So similarly, if I want to decrypt the data back, so we will look at the decryption. So decryption is plain text, we have to retrieve it back using K inverse C mod 26. So let us take an example of how the encryption and decryption is done using the key ciphering technique, which is a block ciphering approach. Okay, so for simplicity, we will take an example of K matrix, which is 2 cross 2, which could be any size of n cross n. So for simplicity, we will take it 2 cross 2. So let us take the matrix of this K as 7, 8, 19, 3. So which is a 2 cross 2 matrix. And the condition is we can't take the matrix any means random numbers of key values. So the key which has been chosen here should have a multiplicative inverse. So that's what the condition required for choosing the key matrix. Okay, so let us take for an example of this key matrix and the plain text. Again, for a simple illustration, let us take a message as Friday. So this message I want to encrypt using the key cipher. Okay, so the approach is we need to map each character with its equivalent values here. So the mapping is something like, so I have the database A, B, C, D till X, Y, Z. So A will be mapped to 0, B will be mapped to 1, C will be mapped to 2 likewise. So this will be 25, 24, 23. So each character will be mapped to equal values here. Okay, so looking at this plain text Friday, so it's going to have a value 5, 9, 17, I is 8, D is 3, A is 0, Y is 24. Okay, so this is the plain text I want to use the key cipher technique. So what we do is, so we will apply the algorithm. Algorithm it says is cipher text is K times P mod 26. So we need to do the matrix operation here. So once we perform the matrix operation, so we are going to get C is equal to K is 7, 8, 19, 3. And then, so just we need to break this plain text into the kind of matrix dimension. The matrix dimension is 2 cross 2, so that's what we are dividing here. So by duplex, 2 likewise. So what we do is, so we will group the characters, so depending upon the size of the matrix. So now we are going to make it as F for ID, AY likewise. So let me write the equivalent values here, 5, 17, 8, 3, 0, 24. Okay, so this is what the matrix we got here. Everything we need to perform under mod 26. Okay, so we are familiar with operating this matrix operations here. So we need to multiply 2 cross 2 with this any dimension. So in this case it is so 2 cross 3, likewise it continues. So if we perform the mathematical linear algebra operation as 7 into 5 plus 8 into 17 and mod 26, it simplifies to 15, 16, 2, 5, 10 and 20. So this everything is under mod 26. Okay, so this is my cipher text. Again, if we map back this data to the characters, it is coming to, so this P, 15 is equal to P, 16 is Q, and 2 is C, 5 is F, and 10 is K, and 20 is U. So this is my cipher text. Okay, so for the message Friday, my ciphertext is this is my ciphertext. So this is what the procedure involved in ciphering technique here. Again, so if we want to retrieve the data back, and the procedure of decryption is, we know it, the plain text is equal to K over C mod 26. So there is some computation involved in computing the multiplicative inverse of the matrix K inverse. Let us quickly check out how do we find out the multiplicative inverse. So K inverse is, so we need to find a determinant of the matrix, and then if I evaluate this as, so this is 3, 7, and this minus 19, minus 8. So determinant is, so 7 into 3 minus 19 into 8. So this comes around 1 by 25. Again, all the operations should be performed under mod 26. So this comes to 1 by 25. Again, if I look at this is 3, 7, minus 19, minus 8. This simplifies to, again, so there is a procedure involved in finding out the multiplicative inverse of 25. If I use a technique called Euclidean approach to find the multiplicative inverse, so you want to get the value as 25 itself. So multiplicative inverse of 25 and the mod 26 is 25. So if I operate this 25 into 3 minus 8 minus 19 and 7, this simplifies to, let's say, 23, 8, 19 and 19. Okay, so this is the simplified value of the K inverse. Okay, so once we find out the multiplicative inverse of the matrix K, so we can evaluate the plain text, which is nothing but, we got the K inverse 23, 8, 19, 19. Now we can plug in the ciphertext. Ciphertext equivalent value if I plug in 15, 16, 2, 5, 10 and 20. Similarly, if we evaluate using the linear algebra matrix multiplication, so it evaluates to, obviously we should get the message again under mod 26, 5, 17, 8, 3, 0, 24. So if we convert the number to back characters, it says 5 is F, 17 is R, 8 is I, 3 is D, A is 0 and Y is 24. So this is my plain text. So we retrieve the plain text back from the ciphertext using the key cipher technique. Right, thank you.